Hello everybody and welcome to this Pipe Renewal Planner example video. My name is Dean Jago from Bentley Systems, and today I'm going to take you through a Pipe Renewal Planner example, how to set up some different aspects and have a look at the end result. So if I open up Pipe Renewal Planner straight away here, you see that I've got 13 different aspects. These aspects are what make up the final score of our Pipe Renewal Planner, and as you can see, each one here is weighted exactly the same for me. Those weightings can change, of course, depending on which aspect you think is more important. These ones highlighted in yellow here are built in with the product, so whenever you open up Pipe Renewal Planner, you're going to see those four every time. Uh, and then the rest I've added on my own. Of course, you don't have to add these ones, and you can add any field that you want, any different aspect you want, whether it's included with WaterGEMS or not. So any information you might have um, in any other product, like an asset management system or your GIS, SCADA information, anything like that can be brought in and used as a different aspect as well. So the first aspect here, the pipe break. If I open up the pipe break dialog here, you'll see that using the import function here, I've already brought in my pipe break data, and you can see that some of my pipes do actually have pipe breaks on them. The two columns we're particularly interested in for Pipe Renewal Planner from the pipe break, the first one here is the break rate of the pipe group, so that's in breaks per year per kilometre, and then the break rate of the scaled pipe, so that's breaks per year per kilometre on the actual pipe. So if we want to see that visually using the color coding here, if I turn on the break rate scaled now, so for the pipes, you can see basically it highlights the pipes that have breaks on them individually. However, Pipe Renewal Planner will also take into account the pipe group. So which group does the pipe belong to, and how often is that group of pipes likely to break? You can see here it gives you a much clearer picture of which pipes are going to get a higher and lower score within Pipe Renewal Planner for that aspect. Second one on the list here is criticality. So when I open up criticality here, you can have a look at all the different segments, and I'll highlight these segments, and you'll see what it's going to do is based on the valve position, so isolation valves or whatever valves you've got in your system, it's going to break it up into, in this case, 2200 different segments, and you can see that each segment has its own color, and these different colors here are each segment that can be individually valved off if a burst occurs. So criticality not only segments for us, what it does is also gives us some outage segment, so outage set length information, and then the actual criticality information here. So for example, the system demand shortfall percentage, and you'll see when I sort that descending now, you're going to get a percentage of demands not being met when each different segment is shut down due to a burst or maintenance, whatever it might be. So those results are now available to Pipe Renewal Planner as well. Third one there is the capacity, the fire flow. So I have gone and run a fire flow analysis. So I'll turn on the color coding here, and you see most of the red pipes here, or the worst pipes, are the dead end junctions at the end of a court or whatever, as well as some longer pipes here that have some quite high scores. So if I turn on my fire flow here, I can also check the fire flow results browser. And when I scroll down, you'll see that some of these nodes have in fact failed. So the failed nodes are obviously going to get a much worse score within Pipe Renewal Planner as those that have passed, based on the constraints that I've entered into the original fire flow there in terms of the minimum velocity and pressure. Okay, so back to Pipe Renewal Planner. The next one's hydraulic risk. Now, hydraulic risk, you'll notice, doesn't have a scenario here, and that's because it's just the criticality multiplied by the rate of failure. So how critical the pipe is and what's the risk of it failing um, with that criticality. So that one's built in. You don't need a scenario for that, and basically it's already done for you. So chlorine average. So what I've done here, and you'll see if I turn on my chlorine color coding, I've got an average residual around the system here that I've calculated over a long period of time, so about 4 days. That's done using the post-calculation processor to then average it out and then put that onto the pipe for use in Pipe Renewal Planner. The leak count here can be done several different ways. So firstly, I'm not going to go through it today, but you can use Darwin Calibrator to find leakage nodes and emitter coefficients and then add those into the upstream or downstream pipe. Or you can use Bentley Utilities Designer and run a leakage study on your system, which is what I've done in this case, and then imported those results into the leak count field here, which I can then use, and I can view those visually as well. And basically you just see different pipes around the system that have leaks on them. The max flushing velocity is again its own module within the analysis menu here, and you'll see that I've run a flushing study, and I've actually run this flushing study on every single junction within this project. And when you do that, and then I'll turn on the velocity for the maximum flushing here and make the flushing output current scenario, you'll see here are the maximum velocities for each particular flushing run, represented on the entire system all at once here. So you can see those that haven't flushed very well. Obviously, we're going to give those the worst score. The next one after flushing is the transient maximum head here. And what you'll probably notice when I turn on the transient max head, you notice that all of them are green except for this one particular trunk main. And that's because I've run the transient analysis on the system, and this is the only pipeline that has a transient event occurring. So all those green pipes are going to get a score of 0 for this particular aspect, which I think is fair given that they don't have any transient action at all. So the pipeline highlighted there clearly does, and it will be scored appropriately in Pipe Renewal Planner. Also, it's worth noting that I didn't run the transient analysis within WaterGEMS. I saved the project, opened it up within Bentley Hammer, ran the transient analysis, saved the results, and then opened it up in WaterGEMS again. So you do need to have Bentley Hammer to run that analysis. So age is the next in the list, and if I turn on the age color coding here and then make the water quality age scenario current, here you see the different ages of the water, and most of the smaller red pipes around the system are obviously dead ends where there's not a lot of flow happening at the end of those pipes, and therefore the water is sitting in those pipes for quite a long time. But you do see entire areas, especially down the bottom right here, where we do have some very old water in the entire subdivision area here. So obviously that's going to get an increased score for the age aspect. So the next four aspects here really aren't their own modules. These are just results that come with a standard calculation run. So head loss, diameter, material, and flow. If I have a look, for example, at one of them for material, I can just grab any of these properties, give it my own score, and you can see I've rated cast iron 100 here, so the worst, down to PVC being 40, so the best, and the same with diameter and so on. So I can give each one a corresponding score to its diameter, with 600 being the worst score because we want to notice larger pipes rather than the smaller pipes because they're more important. So with all of those aspects, you can now go ahead and run it, which I've already done, and have a look at your results. So the particular column that we're interested in is the pipe score, and I'll just sort that so that we can see the worst pipes on top here. You see that my worst pipe has a score of 44 out of 100. 100 would mean that it has the worst possible score in every single aspect. So pipe 4087 here got the worst score, and if I scroll across I'll start to see why that is. So its chlorine average got it a bad score of 60. It has a leak here of 50. The flushing obviously wasn't good. It has a score of 100 there. It has a transient running through it, so it gets a high score there as well. And you can see it's a cast iron pipe and so on. So with all those things taken into account with the weightings, it ends up with a pipe score of 44. So if I have a look at the entire system and their ratings, by turning on my pipe score, here you can see the entire system with the worst pipes in red, best pipes in green around the system, based on all of those aspects. Of course, you don't have to just do it once or with one run and this set of aspects. So I do have a second run here where I've duplicated it, and then I've run some different aspects. This time you can see that I've got some different weightings rather than weighting them all equally. And it's a more water quality focused run. So I've got the chlorine and the flushing, age, diameter material, and some other things here. So really focused more on water quality for this one. And if I go ahead and make this one current with the output scenario of it, you see a completely different set of results this time based on the water quality Pipe Renewal Planner run. Thanks very much for watching this video. If anyone has any questions, please let me know. I'll be more than happy to help. Thank you.